Okay, so starting with what do we see when we look at the planet and the climate over an extended period of time? So bottom left-hand plot, you will have seen before. This is the global mean temperature. It's the famous HAD-CRU-T, so Met Office plus University of East Anglia, thousands of observations around the world to estimate the surface climate and how that's changed over the last 150 years. So this time series starts at 1850, ends at last year. And what you can see is in the first 50 or so years, it's wavering around zero because that's the baseline that we've checked these data against. And then since 1980, a warming of the climate system. So we breached 1 degree in about 2015, and we're now about 1.2 degrees above that pre-industrial baseline. The second indicator that's shown here on the top right is carbon dioxide concentrations. So the present day is zero on this plot, and my apologies for the change in baseline. So that is today. And this goes back 100,000 years. So this is to put those carbon dioxide concentrations into a geological context. And what you can see is that between 100,000 years ago and really very recently, the carbon dioxide concentration has bobbed somewhere between 200 and 275 parts per million in these units. And then there's the big ramp at the end where the carbon dioxide has really increased very, very sharply, right in the far top right-hand corner of the slide. And really the point of this is to show that those carbon dioxide concentrations that we have now, 414.7 parts per million, is unprecedented in the last 100,000 years. And to put that into context, the plot here shows the emergence of Homo sapiens. So this is a very long time, and it's a very unusual event to have such high carbon dioxide concentrations. I will connect those two things in just a minute, but if we could move to the next slide, please. The changes that we observe in the climate system are not limited to temperature. There are many, many other indicators of change. And I will say again, these are just observations. There is no modeling involved in these. This is observing the planet and what's happened over the past decades. So top right-hand chart shows sea level rise since about 1990. And this is the satellite era when we were able to measure sea level globally, and it's a global average of sea level rise. And you can see a consistent increase in sea level during that period. So it's one of the most pervasive indicators of climate change is the sea level. And you're seeing data here from a whole host of different sources, all showing this consistent rise over that 30, 40-year period. And I think Gideon's going to pick up on the sea level rise later in the presentation. The fourth and final indicator that I'll highlight here is Arctic sea ice loss. So it's one of the rapidly changing areas of our climate system right now. Again, since the satellite era in around 1989, 1990, we've been able to monitor sea ice extent in the Arctic around the North Pole. It varies throughout the year, but what we do see is that over the last 40 years, the minimum of that sea ice extent, which happens in September, has reduced by about 12% every 10 years. 12% every 10 years, that's a big number. And what the maps here show you is to give you some sense of what that means. So every year, on average, we're losing an area the size of Scotland. Every 10 years over those 40 years, we're losing an area of the UK, equivalent to the UK and France. And over the whole 40-year period, the Indian subcontinent. So we're losing very large fractions of Arctic sea ice.